Now we're going to return to the deck of cards and draw a couple of cards. We're going to draw a 10 and then draw a face card. So what's the probability of doing that? Well, we see that we have 4 10s, so there's a 4 out of 52 chance of drawing a 10. I've already drawn a card, so now there's only 51 cards left, and 12 of those are face cards. So there's a 12 out of 51 chance of drawing a face card. If we multiply those two together, there's about a 1.8% chance of drawing a 10 and then a face card. The next question, though, is asking something different. It's saying drawing a 10 or drawing a face card. So I'm not drawing two cards, I'm just drawing one card here, but it could be a 10 or it could be a face card. So how many possible 10s are there? Well, there's 4 10s and there are 12 face cards. So altogether, I could have, let's see, 10 and 12 is, I'm sorry, there's not 10, there's 4 10s. So 4 and 12, 16. So there's a 16 out of 52 chance, or about a 0.30 chance, 30.8% chance that I'll draw either a 10 or a face card, because about a third of the cards are either 10s or face cards. Now, if you look at what's being done differently here, the word "and" gives us a clue that we are to multiply the two probabilities. So when we see "and," we think multiply the two probabilities. We do have to take into account, in this case, that the second probability changes as a result of the first event. When we see the word "or," though, we think add these two. Because what we really did was we said there's a 4 out of 52 chance of drawing a 10, and there's a 12 out of 52 chance of drawing a face card, and altogether there's a 16 out of 52 chance of drawing a 10 or a face card. So I'm going to erase this here. This is what we did. Now, so what's the probability of drawing a 10 or drawing a heart? Okay, so if we apply this addition rule, we could say there's a 4 out of 52 chance of drawing a 10, because there's 4 10s in the deck. There's a 13 out of 52 chance of drawing a heart, because there's 13 hearts in the deck. So that would be a 17 out of 52 chance. Now at this point, some of you may be saying, no, 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 that's not right. And you would be correct. That is not right. We have 13 hearts, so if I were to circle all those are all the possible hearts I could draw. And here are the possible 10s I could draw, but some of you have recognized, uh-oh, I just counted one of those cards twice, because there's an overlap. So really, there's only 12 hearts left. If I have a 4 out of 10 or 4 out of 52 chance of drawing a 10, I've already counted the 10 of hearts as part of that group, so I can't count it twice. So actually that's 12. So this is 12 really out of 52 for the other face cards, and this would be a 16 out of 52. So exactly the same probability as before. Not really thinking that I planned, that's kind of coincidence that that happened. But it's not any different because I still have 16 cards in the deck that are either a heart or a 10 or both, okay? So heart or 10 or both, 16 possible cards. We have to remember, don't count the 10 of hearts twice, because it's in both groups. Now, a way we can illustrate the difference between the second example and the third example is by doing something called a Venn diagram. In the second example, we were looking at looking at 10s or face cards. I made that circle a little bigger because there's more of them. In this case, there are 4 10s and there are 12 face cards, and we just add the 4 plus the 12 because there's no overlap in the groups. But if we're looking at the other example, we have the 4 10s and we have the 13 hearts, but there's an overlapping part right here. This represents the 10 of hearts. The 10 of hearts is in both groups. So there are there's 1 in this category. So there's 1 in the 10 of hearts. There are 3 other 10s. I need to undo that. And there are 12 other hearts. So we have 1 10 of hearts, 3 other 10s, 12 other hearts. If we add them together, 3 plus 1 plus 12 gives me the 16 altogether. Let's look at another example now using a chart here. And I'm going to ask you to do some probabilities, a little bit of review here. I'm going to kind of bring this up a little farther so it's easier to see on the screen. So we want to find, this is actually from the class survey, how many students were male, how many were female, how many that had jobs, how many that didn't have jobs. So this is from our class. I had 20 responses to that survey. So what's the probability that a randomly selected student is a male? What's the probability that a randomly selected student has a job? What's the probability that a randomly selected student is male and has a job? We're just talking about one student, not picking a male and then picking someone who has a job, but just a student that has both characteristics. What's the probability that a student has a job given that they are male? What's the probability that a student is male given that they have a job? So all of these are done just a little bit differently. So what's the probability that they're male? Well, we have 3 males out of the 20 in the class. So 3 out of 20, or not 3 out of 20. There's 6 total males, 6 out of 20. 6 out of 20, or 0.3. 30% chance of picking a male. What's the probability that someone has a job? Well, if you look at, do you have a job? Yes. And you go over here, the total yeses were 12. This would be 12 over 20, which is 0.6. So 60% of the people in the class have a job. What's the probability that you're male and have a job? Well, there's only 3 males that have a job, so that would be 3 out of 20, or 0.15. So 15% of the class are males, people are males and have jobs. Now the last one is the given. So remember, what's the probability of the job given that you're male? So we look at the given part, and that restricts us to only the males. So we're only looking at the males. So we're saying now there's a 3 out of 6 chance that that you have a job given that you're male. So 50% of the males in the class have jobs. Now what's the probability that you're male given that you have a job? So now we're going to look at only the people with jobs. And we're saying out of all the people that have jobs, the 12, what's the probability that you're male? So that's a 3 out of 12, or 0.25, 25%. So 25% of the people who have jobs in the class are males. Half of the males have jobs, okay? This is a different question we're asking. Now, what's the probability that a student is male or has a job? Or has a job. What's the probability that the student is male or has a job? Now, remember when we see the word or, that means male or job or both. Okay, so it can include all 3 categories. They're either male, or they have a job, or they are in both categories. That all is included in the or. It's called an inclusive or, rather than an exclusive or, which would just be where the both would not be included. So we look at our chart and we see we have 6 males and we have 12 people with jobs. So would we just add those together? Because if we added 6 plus 12, we would get 18. So 18 out of 20 are male or have jobs. The trouble is if we do that, so I'm going to write down, there's 6 out of, so let's write this down here, that the probability that you're male is 6 out of 20. The probability that you have a job, and we know when we see the word or we add, is 12 out of 20. But the trouble is now we have counted this group twice. We've put them in both categories. We have the 3 males that have jobs are counted among the 12, and they're also counted among the 6, so we've counted them twice. So we really don't have that many people. We have to subtract out that group. We've counted them twice. So really there's less than that. There's really 6 out of 20 males plus 9 more. Or we could say there's 9 out of 20, there's 12 out of 20 with jobs and then 3 more males with jobs. Either way, we get 15 out of 20. Another way to think of this is that we could say, here's the category of males with no jobs, males with jobs, females with no jobs, or females with jobs. So the females get in here because they have jobs. This group of males is in both categories, and then this group gets in there because of males. We could also say, okay, who's not included? Well, the 5 females with no job aren't included in any of those categories, so we know that 5 people are excluded. So 5 out of 20 are excluded, so 15 out of 20 would be our probability, which happens to be, of course, 0.75.